Welcome back to STEM Spool, where I am using 3D printed models to explain scientific concepts that just make so much more sense when you can see them in 3D. The models for these videos come from this book by Joan Horvath. She is awesome, and you can find that book if you would like to follow along and print these models. I'm also putting some of my own models up on Maker World. If we are still talking about simple machines today, these are machines that people have been using for thousands of years in order to reduce the amount of force to complete a task. That's called a force advantage or a mechanical advantage, and it means less work for the same results. It's no wonder people have been using them for so long. The one we're talking about today is called a lever, and a lever is effectively just a beam that rotates around a pivot point called a fulcrum. Where that fulcrum is can create a type of class of lever, but effectively they're doing the same thing. They are changing the amount of force required to lift or lower an object, and you can think of things like a teeter-totter that you've seen in real life. But let's look at these and see how these different classes of levers work. This is a class 1 lever. That means that the fulcrum is near the center of the beam. If it was directly in the center, there would be absolutely no force advantage, but you could take advantage of gravity to help you with lifting or lowering something. The advantage of a class 1 lever is the distance between the fulcrum and where you're applying the force as a ratio. So if we take our weight and we add it to the end of this beam, you can create different levels of force benefit by where you place your fulcrum when you're trying to lift this. A class 2 lever has the fulcrum all the way to one end and the weight closer to the middle, and this changes the amount of force required. A class 2 lever always has a positive mechanical advantage because of the length of the beam, but it's different than a class 1 lever. And I think the best way to understand this is really to print these and feel it for yourself. A class 3 lever still has the fulcrum all the way to the end, but this time the weight is at the exact opposite end. And because of the distance between the fulcrum and the force, a class 3 lever always has a negative mechanical advantage. This might seem counterintuitive. Why would we want a negative mechanical advantage? But what comes into play here is speed. And when you have speed impacting, you can have different force profiles entirely. This is actually how a baseball bat and your bicep works. You can find other examples of levers in things like a crowbar or a can opener. Look around and see what you can find that is actually a lever in the room that you're in right now.